So let's take a look at this problem. It's pretty lengthy. In a recent year, 73% of first-year college students responding to a national survey identified being very well off financially as an important personal goal. Obviously, a state university finds that 132 of a simple random sample of 200 of its first-year students say that this is an important goal. Is there good evidence that the proportion of all first-year students at this university who think being very well off is important differs from the national value 73%? Carry out a 95% confidence interval for the true proportion, P, of all first-year students at the university who would identify being very well off as an important goal. So hopefully you're getting the idea of what the confidence interval detailed. The middle 95% is what we wanted, which made the tails be 2.5%, another 2.5%. So in our Z table, we're looking for 0.025 or 0.975. Oh, something like that. And I think it actually works out perfect in our table. 1.96, it's a little bit more accurate from the table as our critical value. And our standard deviation, no one's been having really questions about calculating standard deviation anymore of the statistic. We've got 132 out of 200. That's going to be our sample proportion, which gives you about 66.66. So that means we're going to put 0.66 in here and the opposite 0.34 here. And somewhere I told you how many people, 200 people were studied. Calculate all this math. I'm getting like 0.0656 or 7. Okay. And we're taking this value, which is our margin of error also, and then we're adding it to our proportion, and we're going to subtract it from our proportion of 0.66. When we subtract, we've got to put that first in order to be able to do it. And this is going to give us our confidence interval, 0.7257 on a range from that to 0.5943. True proportion, we're 95% confident the true proportion would lie within. Now when you look at this compared to the up here, 73% of first-year college students, a national survey, that's not even within this range here. You know, the 95% confidence interval does not contain 73% and, you know, of first-year college students responding to the national survey as being very well off financially as an important personal goal. Is there good evidence that the proportion of all first-year students at this university who think being very well off is important differs from the national value at 73%? I would say yes, it does. But to be more clear, we can try another test called a significance test. And I'm going to try to break it down a little bit for you, but for doing a test of significance, you're basically doing like a z-score. Or when we do the means, we're going to be doing a t-value. You're doing a z-score and finding out what the probability is. And from that probability, what we're going to do is we're going to compare to 0.05. So like we talked about it before, we've got a null hypothesis and an alternative hypothesis in this problem. And if I look back at the problem, it said 73% of the first-year college students are responding to a national survey, blah, blah, blah. Okay? So what we're trying to figure out is what stuff are we going to test from this data and from this question. So I know it gives you 132 out of 200, but this is supposed to be what we're estimating as the true population's proportion. So it should be the national average. It should be attached to the national versus just the one from this university, this sample. Now the question is saying, does it differ from the national value? The other value, does it differ from the national value? So for this one, we're saying, okay, is it not equal to 0.73? It doesn't say less than, it doesn't say greater than. It says, does it differ from this? So then we got to keep in mind at the very end, we're going to be having two tails to compare this to. We've got to use both tails combined in the end. So it's a glorified z-score. If you look on your chart or your formula table, we've got for our standardized test statistic, and it says statistic minus parameter over the standard deviation of the statistic. For our standardized test statistic, we're trying to find a z-score for this. The statistic is what happened in our sample, 132 out of 200. We talked about it a minute ago, wasn't that 0.66? So 0.66 is going to go in this spot. Parameter is what happened from the population, or what happened from the bigger picture, which is the national one, 0.73. Standard deviation of the statistic. We do see this on that formula sheet as well, and it says it right there with this little formula next to it, P1 minus P over N, or we've been calling it P times Q over N. So we've got to use 0.66 over times 0.34 over 200 people. And I think we just actually calculated it before, 0.001122, and then when I square rooted it, I got 0.033496. When I subtract, I actually am going to get a negative number, negative 0.07. 0.033496, and then when I calculate this, it's like negative 2.2298, something like that, for a z-score. So keep in mind, we're trying to figure out where it differs from is going to be the lower portion from negative 2.2298 and positive 2.2298. So if I find one of these tails on the chart, I believe it's like 0.0129. This will also be 0.0129. And if I add them together, 0.0258. This is basically our p-value. We want to compare this to alpha. There is a 2% chance of this occurring, just by chance. We are comparing it to this 5% chance. Basically what this is saying is anything that's lower than 5% chance, we can't really think that that's going to actually occur. So odds are, we'll say that we don't think that could occur. And of course, there's a nice sentence that you got to say and involved with this too. But that's what we're kind of looking, we're comparing this number to this number over here. So when the p-value is lower, than alpha, we're going to reject the null hypothesis. Let's say the p-value was higher. We don't necessarily accept the null hypothesis. We say we fail to reject the null hypothesis. Since the p-value is lower than alpha, we reject the null hypothesis. Got ahead of myself. We can conclude, and the statement, the question said, is there good evidence that the proportion of all first-year students at this university is important, differs from the national value 73%? We can conclude the proportion of students that feel being well off financially differs from the national average. Now, one thing that we didn't do throughout this problem, in either one of these cases, we still have to check for those three conditions. Random has to be stated somewhere. We need to make sure that it's normal, which is NP is greater than or equal to 10 and Q greater than equal to 10. And we got to double check that 10% rule. So there is more to this than just calculating some things. We actually have to do that as well.